Okay, good morning. So today we're going to be looking at Pythagoras. So we're going to be able to find missing sides, both the long sides and the shorter sides, using Pythagoras Theorem. So let's just have a look at the do now questions. We've got solve, which is find that variable or the missing value or the letter. Coefficient, that is the number in front of a letter. So if we had, say, an expression 4x plus 5, the coefficient is the 4, and that actually means 4 multiplied by x. Unknown, again, that's our variable or missing value. An inequality sign has a greater than, a less than, or a greater than or equal to, or a less than or equal to sign. And those are the inequality signs that I've just listed. So moving down, keywords, right angle. Pythagoras theorem is all to do with right angle triangles. It does not apply to any non-right angle triangle. Very important. So you're looking for that either symbol showing 90 degrees, or if you can look where my pointer is, I'm not sure if you can see my pointer on here, that symbol there, which is a right angle. Hypotenuse is always the longest side of a right angle triangle, and it's always opposite the right angle. So you can see here, my right angle's here, it's the side that's opposite it, not touching it. And square root, we're going to need that today. That's the inverse function of squaring. Okay, so let me zoom back in. So here's my example. Is it going to let me use it? It's not going to let me use the pointer zoomed in, so I'm going to have to use it zoomed out. Okay, so if we were to say that this triangle had sides of 3 cm and 4 cm, a really simple example. Now, what Pythagoras theorem tells me is that if I call this angle here x cm, so Pythagoras tells me that the square of a, which we can say is 3, so a squared, plus the square of b, which would be the 4 cm, is equal to the square of c. So if we square 3 and add that to the square of 4, that will be equal to the square of x, our hypotenuse. Now, c is always x in this, is always the hypotenuse in this case. So now I'm going to go further down, and I'm going to say that a squared is 9 plus b squared, so 4 squared is 16, equals c squared, so 19 plus 16 equals 25. Now x is not 25. X is actually the square root of 25, because remember, we've been given c squared. So the square root of 25 is 5. So we can finish that off by writing x equals 5 cm. Now, sometimes you would not get a nice integer answer, in which case, in this lesson, I want you to give the answer to 2 decimal places. So let's have a look. Label the hypotenuse of each triangle, task 1. So all I want you to do is, I've got 3 boxes in each of these. In each of question, I want you to just put h in the correct box, and it should turn green if you've done it right. So my example, I'm going to put h here. Remember, it's opposite my right angle, and if it helps, you can draw that line, but it's pretty straightforward. That shouldn't take you too long. Now, task 2, I want you to find the hypotenuse. So we're going to use Pythagoras in this format. So a squared plus b squared equals c squared. So here's my example. We did do an example similar to this on the other page, so let's just pick different numbers. So let's say 5 cm, that's a terrible C, and 6 cm. And we're looking for, we'll call this y. Okay, so 5 squared is 25 plus 6 squared is 36 equals c squared. So 25 plus 36 is going to be 61. So c is going to be the square root of 61. So you can use a calculator at this point. If we think about our square numbers, it's closest to 64. So it's going to be probably something like 7.9. So you can take your calculator now, and you can say square root of 61 equals, I've got 7.8102, so I'm going to write 7.81. Don't forget your units, it's going to be centimeters. Okay, so some of these will be integers, some of them won't. 2 decimal places, please. Remember that rounding is very important. Task 3, let's have a look. Use Pythagoras to find the missing shorter side. So this time round there's going to be a missing shorter side. So in my example here, let's say that this is 11, this is 8, and this is, let's call this z. Let's use x and y. Okay, so this time round, if you have a look at the top, what I've done is I've actually rearranged Pythagoras Theorem in order to help. When we know c, what we can do is essentially you're balancing your formula here to make one of the shorter sides a subject. So if you have a look on the left hand side, what I'm doing to go to the right hand side is I'm subtracting b squared from both sides, which essentially gets rid of the positive b squared and makes it a negative b squared. So I've subtracted b squared from both sides, and then I've reorganized it. And what this means is, if you know this side, if you know this iteration of the formula, I should say, then you can find any shorter side. So when you're looking for a shorter side, take away the known shorter side, the square of the known shorter side, from the square of the hypotenuse, and then square root. Very similar to what we were doing before. So I'm going to go do 121, which is 11 squared, that's my c squared, take away 64. So 121 take away 64, that's going to leave me with 57. You have to forgive me, I don't have any of my smarty pants shouting out the answer for me, so I don't have to work it out. Okay, so 57. So a squared, or z squared, sorry, equals 57. Again, we're not going to get an integer for this, so a equals root 57, because we're square rooting here. Again, that's closest to 60, so this is probably going to be something like 7.5. So it's closest to 64, sorry. So square root of 57, 7.5498. So I'm going to write that as 7.55. And don't forget your units, which we didn't put in here, but we're going to say cm. Okay, so you can see here that I've given you kind of a clue as the starting point. You can probably ignore that. You're going to be doing 13 squared. Take away the one you know, and then square root. Remember, we do use the squares of each of these. Okay, finally, task 4. Okay, so this is all about problem solving. So this is, I'm not going to give you too much help here, but I want you to think about maybe labeling your ladder problem here if you're not sure which part's which, and then you need to think about what iteration of Pythagoras Theorem you're going to use to solve this. So I'm not going to solve these for you. These are my challenge questions. I'd like everybody to have a go though. And then finally there's an exit ticket. So have a go at that, and that will be it. Thank you.